So this exercise is related to the calculation of energy change or enthalpy change. First part of the exercise, about 17 to 18 MCQs are there. And the second part of exercise is the structure question. So we will do this exercise today. And remember one thing, just recall the idea that whenever a chemical reaction or any reaction happen or occur, so we calculate the energy change or enthalpy change. And how energy change or enthalpy change can be calculated? It is the bond breaking, which is a reactant side, minus the bond forming, which is a product side. So bond breaking minus bond forming will give us enthalpy change or energy change. So this whole exercise, first part, which are MCQs, will calculate the energy change. Sometime we need a bond energy. Later in this exercise, you will find a question related to that. But most of the questions are related to energy change, enthalpy change. And as MCQs are there, so you will have both, like options are also there. So in the first question, chlorine react with ethane to produce a chloroethane. So this is ethane reacted with chlorine, produce chloroethane and hydrogen. The reaction is exothermic. So look, if they give an idea, reaction is exothermic. So what should be the energy change, positive or negative? If the reaction is exothermic, what should be the energy change, negative or positive? So energy change should be negative. So it means option C and D cannot be an answer at all. So it means these are totally wrong. We are left with either A or B, as a reaction is exothermic. Now, how to solve this question? So on the left hand side, we'll do a bond breaking. And on the right hand side, we'll do for bond forming. Bond breaking. So which bonds we are breaking? We are breaking CH bonds. 1, 2, 3, 4, 5, 6. So there are 6 CH bonds. 6 carbon and hydrogen bonds. Then we have carbon-carbon bond is there. So there's a carbon-carbon bond. And then we have chlorine-chlorine bond. 1 chlorine-chlorine. Then we'll just simply substitute the values. Like 6 into CH bond, as the bond energies are given, CH bond is 410. So it will be 410. Plus carbon-carbon bond. Carbon-carbon bond is 350. 350. And chlorine-chlorine bond is 240. So 6 into 410 plus 350 plus 240. What's the final answer? 3050. Okay. So this answer, the bond breaking is 3050. So first, because the reactant side is a bond breaking side, then the product side is a bond forming side. Which bonds are formed? So 1, 2, 3, 4, 5. 5 CH bonds are there. So 5 into CH. So we'll do 5 times CH plus carbon-carbon is there. So carbon-carbon is there. Plus there is a carbon-chlorine as well. Carbon-chlorine is there. And there is hydrogen chloride, HCl, also there. So we separate the two, like the reactant side is a bond breaking, product is a bond forming. Then we have H and Cl. We'll substitute the values only. So it will be 5 times 5 times CH. So it is 410. 5 into 410 plus carbon-carbon is 350 plus carbon-chlorine is 340 plus hydrogen chloride is 430. So when we substitute, what's the answer? 3170. 3170. That's a bond forming energy. So we were having the bond breaking energy and we have the bond forming energy. We need, but the question is calculate the energy change. So how to calculate the enthalpy change or energy change? The formula is the bond breaking minus the bond forming. So the bond breaking energy, when we calculate the bond breaking energy, that was 3050 minus the bond forming energy 3170. So what is delta H, the enthalpy change when we substitute? It will be minus 120. So minus 120, it matches with option B. So B is the right answer. Is it clear, this question, how we can solve the question related to enthalpy change or energy change using the bond energies? Anyone having a doubt?
No, sir, no doubt.
Okay. So moving on to the next question, similar questions are there. All the questions you have to do the same thing. You have to like take the reactant side as a bond breaking side, the product side is a bond forming side, and then calculate the energy change by bond breaking minus bond forming. But some questions, instead of like here, the first two questions, you can see they give you the bond, but sometimes they don't give you, show the bonds. They give you the molecule and you have to identify how many bonds will be there. Later in this exercise, you will find such questions. Moving on to the second question. So reactant side is a bond breaking side. Product side is a bond forming side. So we have 1, 2, 3, 4. So 4 CH bonds are there. Plus carbon-carbon double bond. Look, carbon-carbon double bond energy is given. You do here carbon-carbon single bond. Like sometime what student, a common mistake, that they use a carbon-carbon single bond and they multiply by 2 for double bond. That is wrong. Because a double bond energy and the single bond energies are not multiple of each other. That's why you are not supposed to multiply. You just have to use the same energy what is given in the question. And then we have hydrogen, hydrogen. We substitute the values. So 4 into CH. 4 into CH. CH is how much? 410. Carbon-carbon double bond 614. And carbon hydrogen 436. So when you add, you will get 2609. That is a bond breaking energy. I'm not checking the calculation, so in case if it is wrong, just let me know in the chat. Then for bond forming energy, 1, 2, 3, 4, 5, 6 CH bonds are there. So it will be 6 into CH plus carbon-carbon. So 6 times the CH bond energy, which is 410. And the carbon-carbon is 350. We just substitute the values. We get 2810. So 2810. This is a bond forming energy. Now we need the energy change. How to get the energy change or enthalpy change? It is a bond breaking minus bond forming. So bond breaking was 2690 minus bond forming is 2810. When you simplify, you will get minus 150. For enthalpy change is negative 120. So option B again is the right answer. Is it clear, this one? Question 2 about the enthalpy change, how it can be done or calculated?
Yes, sir, clear.
Okay. Moving on to the next question, a similar, but look, what is the difference here? In this question, all the first two questions you were they were showing the bonds, but this question the bonds are not shown. So if the bonds are not shown, first you have to show the bonds and then calculate. So we have to draw the structure of CH4. So what is the structure of CH4? CH4 means carbon bonded with 4 hydrogen. And O2 means oxygen double bonded with oxygen, because oxygen belongs to group 6. So it will share 2 electrons. That's why there will be a double bond. But there are 2 molecules. So there will be another molecule. This is the reactant. For product side, what we have? Carbon dioxide. So this is carbon dioxide. And we have water molecules. The structure of water is HOH. But there are 2 water molecules, so it will be HOH again. And now we will solve reactant side. Reactant side is a bond breaking, and the product side is a bond form. So first 4 CH bonds are there, plus oxygen double bonded with oxygen 2, because 1 and 2. We just substitute a value for CH bond is 410, and oxygen double bonded with oxygen is 496. So 496 into 2 plus 410 times 4. When you multiply, you will get 2632. That is the bond breaking energy. Then the bond forming energy, you have oxygen. So 2 of the bonds are oxygen carbon or carbon oxygen double bond, 1 and 2. And 4 bonds are there because 2 water molecule contain 4 OH bond. So 4 OH bonds. So 2 into CO. CO is how much? 805 plus 4 into OH, 460. So 460 times 4 plus 805 times 2, and we'll add them. So we'll get 3,450. 3,450. That is the bond forming energy. Now to calculate the energy change, it is bond breaking minus bond forming. So the enthalpy change or energy change, which is the bond breaking energy minus the bond forming energy. The bond breaking energy, it is 2,632. The bond forming energy, 3,450. When we simplify, we get minus 818. So D will be the right answer. So again, the same thing, but what was the difference in this question compared to the previous 2 questions? That this time, instead of giving the structure, the molecular formula of a element or a compound was given, and you have to identify first how they will have the bonds and then count the number of bonds. It's not about the number of molecule, it's about number of bonds. Like example, in water, it's H2O, but the bonds are 2 OH bonds are there. That's why 2 water molecule contain 4 OH bonds. Same thing, carbon dioxide is 1 molecule which contain 2 carbon oxygen double bonds separate. Moving on to the next question. A similar question is there. As the molecular, like hydrogen peroxide structure is given, but water and oxygen, like in this question, what is the difference here? That 1 molecule structure is given and other molecule structure is not given. But you have to write make the structure first. It's structure in terms of bond. So H2O2 structure is given, which is HOONH. So in hydrogen peroxide, 2 molecules of this number shows the number of, this coefficient shows the number of the molecule. 2 molecules of hydrogen peroxide. So there should be another one, HOONH. And for water molecule, Water is H2O, which is HOH, but there are how many molecules are there? Two. So there will be two water molecules. Why does oxygen form a double bond with other oxygen? Why oxygen cannot form a double bond with another oxygen water? Because there is no other oxygen available. There are two hydrogens available. There's like formula of the water is H2O. So there's only one oxygen and two hydrogens are available. That's why it is forming a single bond with each hydrogen. So structure of a water molecule is H2O. And the structure of oxygen, it is O double bonded with them. Then after drawing the structure, because only one water molecule is there, in 2H2O, what is the meaning of 2H2O? 2H2O means there are two water molecules. 2H2O means two water molecules. Each water molecule contains two hydrogen and one oxygen. So this is one water molecule, then there will be another one. In H2O2, because there are two oxygen available, if oxygen form a double in hydrogen peroxide, if oxygen form a double bond with another oxygen, then there is no bond available with hydrogen. It cannot form a bond with hydrogen, so it won't form hydrogen peroxide. That's why oxygen is forming a single bond. So first we have a reactant and a product. Reactant side is a bond breaking side. The product side is a bond forming side. So bond breaking energy, 1, 2, 3, 4 OH bonds are there. OH or HO is the same thing. And 1 and 2 oxygen bonds are there, single bonded with oxygen. Because like this 1, 2, and there are 4 OH bonds are. And we just substitute the values. 4 into OH, which is 460, plus 2 oxygen single bonded with oxygen 150. So we got the bond breaking energy, which is 2140. And bond forming energy, 1, 2, 3, 4 OH bonds are there. And one oxygen double bonded with oxygen. So 410, 460 into 4 plus oxygen double bonded with oxygen is 496. When we simplify, we get 1336. And then we to get the energy change, it is bond breaking minus bond form. The bond breaking energy is 2140. Bond forming energy 2336. When we subtract, we get a negative minus 196. So minus 196, so B will be the right answer. Is it a clear discussion? So as I mentioned, sometime the question, they give you the structure, the bonds, which you just check how many bonds are of each type of bonds, and then bond breaking minus bond forming. But some question, they might give you a molecule and you have to draw the structure of a molecule first, identify the bonds, and then from those bonds, find the bond breaking and bond forming, and then the energy change. In question 5, ethene is burned in oxygen to form carbon dioxide and water molecules. So reactant, here bonds are given, so we don't have to separate them. The reactant side will be a bond breaking side, and the product side will be a bond form. So 1, 2, 3, 4 CH bonds. Carbon double bond with carbon bond is there, and 3 oxygen double bond with oxygen. So 4 into 410 plus carbon-carbon double bond 610 plus 3 into oxygen-oxygen double bond 497. The bond breaking energy 3407. For bond forming, look, two molecules of carbon dioxide. So this is one molecule, then there will be another molecule like this. So if the one molecule contain two CO bonds, so two molecules contain four CO bonds. OC or CO bond, four will be there. Why four? Like in one molecule, there are two OC or CO bond. But if there are two molecules, they will have four. And same thing, in one water molecule, there are two OH bonds or HO bond. But in two water molecules, there will be four. So this will be 4 into CO. And this will be 4 into OH. The bond forming energy is 5,060. Okay. 5,060. What is the energy change? It will be bond breaking minus bond forming. Maybe you have to, like the bond breaking energy, you have to check. I'm using your values only. So first was 4 into 410 plus 610 plus 3 into 497. This was 3,741. So 3,741 minus 5,060. So this is a bond breaking minus bond forming. So bond breaking energy 3,741 minus 5,060. It will give us minus 1,390. So C will be the right answer. Is it clear discussion about enthalpy change, calculation of enthalpy change using the bond energies? Same way, discussion is there. Some bond, the molecules, as the molecules are given. So when molecules are given, you have to first sort out as H2 means hydrogen, hydrogen single bond, and how many molecule? Two. So you have to do two molecule, and O2 means oxygen, oxygen double bond. This is a bond breaking. Bond forming H2O or water is there, so which is HOH, and how many of them? Two water molecule. So there will be two water molecule. Reactant side is a bond breaking side. So it will be 2 into HH plus O double bonded with it. So it will be 2 into HH, how much? 436 plus oxygen double bonded oxygen 496. And here the bond forming energy 4 into OH. So 4 into OH or HO 460. So bond breaking energy is how much? 1,368, and bond forming energies 1,840. So we get the energy change bond breaking minus bond forming. So 1,368 minus 1,840, which is equals to minus 400 and equivalent to minus 472. So Negative 472, which option it matches with? It matches with option C. So C is the right answer. Is it clear discussion? Anyone having a doubt till this point?